Welcome everybody to the Snowflake office. This is not my home office, but I work for Snowflake. And this is, thank you. I'm constantly surprised by the Snowflake offices I show up at. I'm like, wow, they just keep getting better and better. So yeah, enjoy it. Hopefully in the future we'll have, this is actually the first open source meetup that we've hosted at this office. And we're hoping it's not the last one. And so yeah, keep an eye out for more of them and so you can join more of the office. But yeah, so now to get to the point of me being here. So hi everyone, my name is Danica Fine. I am a developer advocate. No, I'm not. I'm a manager of developer advocacy at Snowflake. Sorry, new promotion, testing out titles here. But anyway, so I focus exclusively on open source at Snowflake. And so predominantly that means Apache Iceberg and Apache Polaris. But seeing as I have a rich and long history with Apache Kafka, I like to build out talks that kind of showcase the synergies between the two of them. I also hate the word synergy, so we're off to a great start here. So tonight's talk is called Iced Coffee, only because I need some sort of motivating theme in order for me to have fun delivering a talk. And so it all makes sense. I think so. We've got real-time data in my mind. That temperature would be hot, and we've got Iceberg, and that is cold. So we're going to take that hot Kafka data, and we're going to chill it down, ice that coffee. It works better in Germany. People snickered at this title there. But in this talk, we're going to show you how to take your Kafka data and what are your options for actually moving it into Iceberg tables. Now, before we get into it, how many of you have worked with Iceberg? Okay, this is for the rest of you. Great. Ooh, and of course this isn't going to work. Perfect. Cool. So first things first, what is Iceberg for all of the people who did not raise their hands? Well, the quickest way to put this out there is it is an open table format optimized for large scale data sets in data lakes. So how it does that, and as we'll see on the future slide, it does that by adding an extra layer of metadata on top of the columnar data that you're probably going to be storing or throwing into your data lake anyway. So Iceberg is kind of, you can think of it as like the love child of a data warehouse and a data lake, because data lakes are kind of messy. We just throw a bunch of files into it and we hope that we can make sense of it later on. But data warehouses didn't really have all the flexibility that we wanted. You have that tightly coupled storage and compute. And so Iceberg entered the game to kind of bridge that gap and take all the good things that we liked about data warehouses, structure and governance, an actual schema. Ooh, those are nice sometimes. And combine that with the things that we liked about data lakes, which is more of that flexibility for a lot of tools. You're not tightly coupled on that storage and compute. And being able to put unstructured data and semi-structured data in there as well. And so it's also optimizing for those things and minimizing the things that we didn't really like. You have more flexibility. So Iceberg is really great because what you're able to do is kind of write that data once in Iceberg tables. You can handle all the data, the types of data that you want to in there, and then you can use whatever Iceberg compatible tools downstream that you want to. And so we store that data once, and then we can kind of take that data to wherever else we want it to go. Okay, so we're maintaining that decoupling there. And as far as Iceberg is concerned within the Kafka ecosystem, I think it's a really, really great add-on to your Kafka architecture because it gives you a cheaper way to sort of offboard your data out of your Kafka cluster so that you can do longer-term analytics with whatever tools that you want. You don't have to maintain everything in Kafka topics forever, even though you can. You're more than welcome to. But it does give you that option for offboarding it. So I think it kind of integrates nicely with your real-time stack. Right, so that's kind of Iceberg in a nutshell, but we need to dive a little bit more into it and look at its architecture, and this will come up later, I promise. We're going to take sort of the scenic route to the topic of tonight. So as I said before, Iceberg is a layer of metadata that that will then organize and coordinate our data files that we want to be storing in our data lake anyway. So what makes Iceberg interesting architecturally is that it doesn't rely on any specific directory structure to actually organize those files. Okay, and so if you've tossed things into object storage before, you know that there's some limits on certain endpoints and certain directories. So we can get around that because we're not relying on that structure there. All right, so we have some data files. Let's then track that with some metadata. So we're going to work from right to left, backwards here. So the first thing we have are these manifest files. And manifest files are going to track a subset of the data files that we want within a single data set. Okay, so this is all for one Iceberg table. Okay. Within our manifest files, we're actually keeping track of the column bounds of each of the columns that are being tracked of those data files that we're tracking. So we have a subset of data files we're looking at. We're keeping track of the max and min of the values in those columns. This is going to make it easier for us later on to pair off data that we don't need when we want to query it. Okay. Next up, we have a manifest list. We're really good at naming things here. So it's a list of manifest files, surprise. But it's a little more coordinated than that. So each manifest list is going to point to a list of those manifest files for a specific snapshot of that table as it's evolved over time. Okay. It also has, rolls up some of those statistics to the partition level as well for us. And then finally, for our metadata layer, doesn't get better than manifest file and manifest list, right? But it does. Metadata file, yeah, well named. And so the metadata files are going to track all of the snapshots up until that point. Okay, so you'll see here we have an old snapshot, an old metadata file with just that snapshot 0, and at the bottom here we have multiple snapshots. And this is so that we can time travel. So with Iceberg, that's one of the features that you have available, is that as your tables evolve over time, you can look back at previous snapshots, get an idea, and actually query the state of the table at that point in time. Okay. So that's Iceberg's architecture. We've got a lot. There's a lot of metadata, but that's not all. There's one more component that we need here. This is just a bunch of files. Yeah, we need one more component to actually make this feel a little bit more like a database, and that's a catalog. All right, and our catalog is going to keep track of all of the individual tables that we want to be storing in our data lake, and it's going to maintain a reference to the latest metadata file for that table. All right, so if we're querying table 1, great, it's going to point to that metadata file, and then we can go from there. Our query engine can go and parse the relevant data for us. Okay, so speaking of catalogs, this is actually kind of important in Iceberg because Iceberg, you can't do Iceberg without a catalog. You need to know what tables you're working with so that they can point to those recent files. And so at a most basic level, they are there to just help you discover and interact with those tables. But more importantly, they're there to ensure consistency when you have multiple readers and writers, right? One of the selling points of Iceberg is that you write your data once and then all these other engines can work with that data. And so if you have multiple of them operating on that table at once, we want to be able to update accordingly and have it function properly. Iceberg does not ship with an official implementation of a catalog though. That's cool, but it does provide a specification on how these catalogs should actually operate, an interface for that. And so there's also implementations of clients that can talk to catalogs like Hive and JDBC to name a couple, okay? So there's a lot of Iceberg catalog implementations out there. Other people are building sort of open source ones available for you to kind of choose from. But as per the interface, the only requirements for that catalog is that we provide a means for mapping that table identifier to the current metadata file, right? Okay, so we saw at a high level what the key components of Iceberg are, that metadata layer, the catalog, and now we can kind of focus on how we actually interact with our data, because remember, we're offboarding the data from Kafka into Iceberg so that we can do some interesting analytics and have that flexibility down the line with a query engine. So conveniently, the Apache Iceberg project ships with 2 implementations, open source implementations for compute engines. We have built-in support for Flink and Apache Spark. Both are great options out of the box, and we'll get into those later on. But beyond that, the Iceberg ecosystem is healthy and growing. So again, sort of focusing on that interoperability. You write that data once, and we can use all these engines for whatever use cases that they might be better at, right? And you can switch that whenever you want, okay? So once you've gotten started with one of the compute engines, because a lot of you said you haven't really looked at Iceberg or thought about Iceberg before, it's as simple as writing a query to interact with your Iceberg tables. If we're keeping track of data related to just bookings, it's a simple data set. So create table is going to feel very familiar. It's SQL, inserting then your data into the Iceberg tables, and then selecting. I'm not going to go in too much into this because we're focused on the actual moving of that data. So one more stop on our scenic route, because this is actually really relevant to what we're going to get into as we help you choose which method you want to use to move your data from Kafka to Iceberg. Right? The first thing you really need to know as you kind of level up your Iceberg knowledge is, and for those of you who come from the Kafka background, data files are immutable. That's okay. That's completely fine. Messages, records, and Kafka are also immutable. You should be fine with that. And so when we kind of think about how to delete data then in Iceberg, things get interesting, right? When you think about deleting data from a Kafka topic, what does that actually mean? Well, if you have compacted topics, we've got tombstones. There's kind of like workarounds to actually move your data and delete your data. So in Iceberg, it's also pretty interesting when we think about deletions. There's two ways to think about deleting your data from Iceberg tables. We have copy on write and merge on read. So in copy on write, we have 3 rows in a data file, and we want to delete that 3rd row with the espresso line. Then we are just going to write a completely brand new file without that row in it. Yeah, so when does this deletion happen? Well, it happens when we write the data initially, hence copy on write, okay? With merge on read, instead of just rewriting the file, what we're going to do is we're going to keep that existing file as is, and then we're going to introduce a new delete file in order to track which records are no longer relevant to us. Okay, and there's 2 ways to do this also. The first way is by using something called an equality delete. So in this case, the equality delete could potentially apply across multiple data files, and it basically just says, okay, after time t1, if we see any records before that T1, before that timestamp, and it meets this this equality match, like it has that that element in it, espresso in this case, then we're going to ignore it. When do we ignore it? On read. Okay, so this puts the onus of deletion on the actual reading engine at that point. Okay, so that's an equality delete, but then we also have a position delete. So position deletes can apply, again, across multiple data files, but we get way more specific. We don't say, oh, we're just trying to match an element here. We say, look at this file, A, and we're going to remove the element at index 2. Okay, it's no longer important to us. Okay, and again, we're doing this on read. Okay. And so equality deletes are generally said to be useful for streaming use cases because you kind of get that like tombstone-esque sort of thing. This element or these elements that match this thing are no longer relevant to you, versus, which is kind of akin to what you've got in Kafka. Okay. Beyond equality delete files, we can also, beyond equality delete, yeah, nope, already got that, great. Now, looking at these 2 options, I have a question for you all. Which one feels like it works more with the sort of streaming world? Copy on write or merge on read? Merge on read. Because we want our writes to be as fast as possible, right? So we could just throw all of our Kafka data into an Iceberg table as we go. And so we really do want to put the onus of deletion on our readers, okay? So it's also worth noting, again, I mentioned that these are more akin to sort of like how we deal with tombstones in Kafka. Position deletes, if you're dealing with Kafka data, especially if you're working with Flink, as we'll see later on, equality deletes are like really important. But position deletes are generally seen to be more performant. So this is something that we're going to have to factor in later on as we decide which way you want to be moving your data from Kafka into Iceberg. Okay. The thing to think about when we have these deletions in here, as we said that merge on read is going to work better for streaming, right? But now we have this fun additional problem that we've made for ourselves, and that is that we have small files, right? And the copy on write, we are copying over the data without the rows that we don't want, right? When we go to merge on read, we are adding these deletion files. Okay, and the data files, the deletion files are immutable. So we're going to have, for as many deletes that we have, if we're not doing a bulk operation, we're going to generate a lot of extra deletion files that are just going to be lying around. And in Iceberg, this file I/O is a killer of performance, right? The entirety of Iceberg is just files that are floating around. So when we are querying that data, we want to minimize how many files we want to open. Okay. So small files, there's something that you have to keep track of, not even just for in the case of merge on read, but generally in Iceberg, depending on how your write operations are actually grouping data together to write. And so generally speaking, we don't want small files. We want to minimize the number of small files that we have to be more efficient. And so to fix that, the solution is to just have fewer small files, right? But how do you actually do that? And so as we said, copy on write is going to help us avoid a lot of small files, generally, but that doesn't really help us for this streaming data. So what we could do is maybe, all right, just reduce the number of small files from the get-go and try to be smarter about how we are partitioning our data, right? This is also a problem in Kafka. You know how you have hot partitions and then some other ones are kind of neglected, and there's a lot, in this case, going to generate a lot of small files for certain partitions. So you also have this fun game in Iceberg on choosing your partitioning fields optimally, okay? And so how do we get around this? Like if you don't want to go through the trouble of trying to figure out all of your partitions and making it optimal, well, what we could do is later on, we could run a compaction task, okay? And this is something that is built in for Iceberg, and it's actually so important it deserves its own slide. So the idea with compaction, as it sounds, is that we're going to take these smaller files, read all of the data from them, and these are going to be small files from a specific partition, and we're going to rewrite them, apply and reconcile any deletes if we have those delete files in there, and then group them into a smaller number of files that are larger. Okay, so this is fully configurable. It's built in with an Iceberg action through Spark specifically, so this is a maintenance task that they have available as part of that engine. Rewrite data files, and you have a lot of levers that you can pull with this, but generally it's a maintenance task that you want to be doing pretty frequently. Okay. So we saw how small files are going to help. We want to get rid of those. So I want you to keep that top of mind on like this maintenance task. So that's going to come up later on. Okay. So now Kafka to Iceberg. We can finally do it. Okay. What are your options? Well, you have a few. Otherwise, we wouldn't be here. Some of the biggest ones. So we've got Apache Spark. This is where I bring the Kaf-fee back. Okay. Apache Flink or Kafka Connect. These are all familiar things to people in the world of Kafka, right? See, I did that on purpose. So as we get into these and dive into them a little bit further, you're going to see that each of these options are going to feel, in different ways, they're going to feel like the natural choice. Okay, so if you're approaching this problem from someone who uses Iceberg, which only like 5 of you do, then you're going to feel like Spark and Flink are going to be very natural choices because they are built-in compute engines from the Iceberg side of things. Okay, if you are approaching this from the Kafka side, which 99% of you will be, Flink and Kafka Connect, like staying within the Kafka ecosystem, like close to that, is going to feel way more natural and something that you're going to be more comfortable with. So let's break it down and maybe we'll flip some of those preconceived notions on your head. So with Spark to begin with. So it's a first-class citizen from the Iceberg project's standpoint. It's maintaining, we have a full implementation of that that's maintained by the Iceberg community. So that comes with a lot of benefits, namely when, as I said, when you're maintaining your Iceberg tables later on, because you will have to do that at some point. And so we do have a lot of Spark actions, maintenance tasks that are built in for you to use. So it's nice just to reduce those mental cycles. If you're thinking about maintaining your Iceberg tables long-term, cool. Let's also have the task for moving data from Kafka into Iceberg done through Spark as well, okay? It's also worth mentioning that if you're not already using Spark, maybe don't. It's going to be a lot for you if you're just using it to move your data into your Iceberg tables for a critical process like this. As far as like the technology goes, the functionality goes, Spark's going to be pretty high up on this because it's just so flexible as a technology, right? It's tried and true. There's so many different inputs that you can sources and sinks that you can use with Spark. And so, yeah, for those of you who have used Spark with streaming, or if you've thought about it, you also know that like Spark is not really streaming. It's fake streaming. Okay, so you have to ask yourself if that matters to you for your specific SLAs here. Okay, Spark is great at handling. We've got append. So if you want to just blindly add data to your Iceberg tables, for overwrite, it has that functionality built in as well, and that's really useful. That's where you kind of rewrite an entire partition's worth of Iceberg files. That might not sound very useful. But you can imagine if you have some compact topics, and maybe at the end of the week you have a task that you just want to sync all of the data from that compact topic and rewrite everything for that partition in your Iceberg tables. That's where I think it might be useful. And so having overwrite in Spark is can be useful. Despite that built-in surprise with overwrite, Spark does have some limitations. So we have write, we have insert, we have merge, upserts. You can technically do them in Spark, but maybe you shouldn't. There's a pretty big workaround there with a temporary table. You have to use for each, and then you have to remember to clean things up at the end so your catalog isn't burdened with that extra metadata. So there's trade-offs here. Another annoying but not critical, I don't think it's critical, thing to consider from the Spark side is that it doesn't handle equality deletes. So equality deletes were really only introduced, I think, to the Iceberg project because of Flink users for sort of this streaming use case. So Spark doesn't do it, okay? And speaking of streaming, yeah, there's a general limitation on the Spark side, like what is streaming? I'm going to say that, for as much as we talk about like, oh, are you doing streaming with Spark from Kafka? It's not really going to matter here, because if you're asking yourself, like, why are you actually syncing your Kafka data to Iceberg? It's because you want to be doing long-term analytics. Like your SLAs are going to be like much less strict on that side of things. So if it takes you an extra couple seconds to do that microbatch from Spark, it probably doesn't matter. Okay, so ask yourself if it matters. And a bonus for this, all of the options actually offer this, but we have a fast append mode. So for all of that metadata that we have to be writing for our Iceberg table when we write new rows, that's a lot. And sometimes you can optimize Iceberg to kind of rewrite some of the manifest files and some of the metadata as we're adding new data. And so with fast append, we're not going to bother with that. We're just going to add the data file, update as little as we have to in the metadata, and move on. So this is useful from the streaming perspective. All right, Flink. Obvious win again here is that it's a supported compute engine from the Iceberg project. And so this means that you're going to be interacting with your Iceberg tables natively using the available Iceberg connector. And so when you think about your Kafka to Flink to Iceberg pipeline, you're going to be writing a Flink job with a Kafka source. You're going to conduct any transformations in there in real time, which is great. That's a benefit of having Flink in there. And then we have the Iceberg sync to write that to our Iceberg tables. Annoyingly, confusingly, there are actually two Iceberg syncs supported by the Flink project. There is naming is hard. There's the horribly named Flink sync. That's what they called it. Yes. And then we have the Iceberg sync. Yeah, better, we got it better. So Iceberg sync, relatively new. It's based on the V2 Flink sync abstraction. So we've got some extra goodies in there exactly once, yay. Small file compaction to a degree is supported from this updated Iceberg sync. And then they're also kind of thinking about adding some inline maintenance tasks there as well. So we might reach parity with the Spark project at some point. Okay, so keep an eye out for that. And again, of course, I need to call out the fast append because that's important. And finally, you could use Kafka Connect to move your data from Kafka to Iceberg. The Kafka connector implementation was only recently donated to the Iceberg project. Before this, it was owned by Tabular. So it is kind of relatively new. It's fully functional, but I really think the open source community is now trying to figure out what needs to be done if there's extra things that we want to add to it. The connector, it's worth calling out that it's kind of cool the way that they built it. So they have a centralized commit model where there's a coordinator that pulls all the data from the incoming partitions and kind of batches it a little bit so that we have more control over how much data we're actually writing at once to Iceberg. This is going to help obviously to mitigate our small file problem. Okay, but there is going to be that trade-off, right? When you think about when you batch for your producers in Kafka, there's always that trade-off between the latency and how much data you're writing. So this is going to be a fun, additional exercise for you all. Okay. Yeah, so benefits of Kafka Connect, it's native within the Kafka ecosystem, so we've got that exactly once semantics. If you need to do some transformations, of course you have whatever you can get away with a single message transform, which is great. And so yeah, it has pretty much all the bare bones there from Kafka Connect. It's pretty easy to use. And then also we've got fast append mode there. So I know we're getting kind of close on time now, but for a wrap up, I can't tell you which one to use. I'm just here to relay the information, what you can choose. So I want to summarize some of the pros and cons here so that you can, at the end of this, get a nice photo, a good understanding of what's going on here. So Flink, I think this is a great option, Spark. It's a great option if your team is already familiar with running Spark jobs, right? If you're already doing this, wonderful. It's probably going to be one of the best and most flexible options for you to get started, although Flink is a close runner-up. Again, with the streaming, but I think we're probably over that here. And the situation where I kind of envisioned folks using Spark more than the other options is if this operation of moving your data from Kafka into Iceberg is being requested by maybe another team that owns your data lakehouse, owns the Iceberg instance for you, okay? So you are just the people who are, maybe you're already using Spark for some other things, but somebody else is maybe maintaining that for you long-term. Yeah. For Flink, you do get a lot. We get the actual stream processing, flexibility to do batch as well, CDC exactly once, equality deletes only because they invented them. Cons, I mean, if you're not already using Flink, again, you don't want to add too much extra tech to your stack if you don't need to. Other big cons to think about is that schema evolution. This is something, again, a selling point for Apache Iceberg. Can you do it in Flink? Yes, but then it becomes not real time because you actually have to pause the job and kind of refresh it. Hidden partitioning is another selling point of Iceberg that we didn't get into. And this is that you can actually partition your data based on a timestamp field and actually partition it based on a transformation of a timestamp field. And the downstream users who are querying that data don't need to know about that. Okay, so they can query that timestamp based on like the year or just the day of that. And the engine is aware of how you've transformed that. So they don't have to know what logic went behind that. But can you do it in Flink? No. So that's a shame. And then of course, the biggest con I think is the limited maintenance tasks, which they might be sort of fixing there for you. Okay. Why should you choose Flink? Well, if you are already using Flink, right? Again, don't add more to your tech stack if you don't need to. This will get you pretty far if you're just trying to move your data from Kafka to Iceberg, okay? And again, think about if there's another team who's maintaining the Iceberg sort of instance for you and maintaining those tables for you, this is going to be a pretty attractive option for you. And finally, Kafka Connect. We get the exactly ones. Another cool thing we get is table and database fan out. And then of course we actually do get schema evolution for free without having to think about it from the Kafka Connect side. Only real cons is that, okay, we don't have maintenance, which is actually a huge con. Okay, so you are absolutely relying on someone else maintaining your Iceberg tables long-term, or you are committing to running Spark jobs at some point to maintain your Iceberg tables. And then there's limited processing or whatever you can get out of an SMT. Okay, so that is your quick survey of options for moving data from Kafka to Iceberg. I hope I've given you a lot to think about. And of course there are more, there's a lot, as I showed you on that slide, there are a lot of compute engines out there, and if any of them have Kafka inputs, of course you're more than welcome to sort of play around with those and sync them there. But these ones are a little more real-time friendly. And so with that, and all of that information, I'm going to leave you with a link to my link tree. I have a lot of resources that I'm adding there pretty regularly on Iceberg, on Kafka things, on Flink things, on all things, random things too. But the biggest thing that is up there now is that if you really want to learn more about Apache Iceberg, we just had Iceberg Summit a couple weeks back, and all of the recordings are on YouTube. So there is a handy link there for you all to peruse and learn more about this technology. And so with that, thank you.